Hi all. Today we are going to discuss a very important topic in C++. Uh, that is how C++ is organizing the memory to store the different kind of data types. This is a very important thing. Every C++ developer should have a clear idea about how C++ is handling the memory. So, since this is a very important thing, instead of directly discussing the C++ memory management, we are going to derive the concepts from very well-known real-life examples. I hope that since this is a very important thing, deriving such a method will help you to understand the concepts more well. Think that we have an parking space. We need to manage this parking space, right? For a parking space we have a very big parking space like this, and we have a lot of vehicles, right? Vehicles are different sizes. It may be bike, car, minivan, or a bus. We have to park these vehicles in our parking area. So, what's the very straightforward way? We park it somewhere. Whenever the new vehicle comes, we park it somewhere. But this is not a good way, right? So, if we park it in this way, if we have a very big parking area, when the owner comes back, it is very difficult to identify where the vehicle is parked, right? So, this is not an efficient way to manage a very big parking area. So, what we can do is normally what we do is all the shopping malls or all the parking areas, we could see that it is divided as slots, right? Then we can easily identify the slots. Whenever the owner comes, we can easily say that your vehicle is parked in this particular slot. Just go there and take your vehicle, right? So that's a very easy way. But the problem here is we have a different kind of vehicles, right? A different size of vehicles, right? If we arranged our parking area in same kind of spaces, that means a small space that can be used to park a bike only. How we park the car that is more bigger than the bike, right? We cannot park a car in this small area. So how we manage? So we can manage it this way, right? When we create the slots, we will create the different kind of size for each slot. For example, we create a small space slot like this one, and a little more bigger slot that can be used to park a car like this, a little more bigger. And for that above, we will create a very big parking space. Okay, our problem is solved. We can park all kind of vehicles, right? But the problem is one day uh, it comes lot of bikes to park, right? So in that case we arranged the parking area like this only, right? So even though bike not require a lot of space, it needs to take the entire space, right? So this is a wastage of space, right? It is a very big wastage if we consider the very big space that we designed to store a bus, right? So this is not an efficient way to park the vehicle, right? So we have to find a little more an efficient way to park the all kind of vehicles. All kind of vehicles means all kind of vehicle that has different kind of sizes, right? So what we can do is we can create an efficient, a more efficient parking space, right? uh, like what we done earlier, we divided the parking area as same kind of slots, right? uh, the single slot can accommodate the smallest vehicle possible. In our case, the smallest vehicle is a bike. So we designed that all the slots are the same size that can be that can be used to park a bike, right? Like this, we designed. And what we done is we created a common knowledge like this. Bike takes one slot, minivan takes three slots, car takes two, and bus takes 4 slots. We created a general knowledge or general information like this. We keep that information in our area, in our site, right? So when a bike comes, what we do is we park it in an area and we keep an additional information in our book or somewhere. We keep this information. We only needs to keep that where it parked and what is the kind of vehicle. Only these two information we will keep in our register, right? So when a car comes, it requires two slots. We park it in 2 and 3 slots. We use 2 slots because we know that car takes 2 slots, right? And in that case also, in our register, we only need to keep the same kind of information as we stored for the bike. The initial slot number, that is the 2, we parked the car in 2 and 3, so initial slot number is 2, so we kept the 2 only. And in the case of vehicle type, we kept that vehicle type as car. We know that car takes 2 slots. Okay, so when we manage the vehicle and manage how much spaces are occupied, how much spaces are vacant, we can easily calculate using these two information, right? When we see that the car is parked in the second slot and the vehicle type is a car, we can easily identify that the 2 and 3 is already occupied because car takes 2 slot. We have that information, right? So using this information, we can manage any kind of vehicle, right? If we needs to park a bus, we park it in the seventh slot, 8, 9, and 10 because we know that bus take 4 slots. We only need to keep the same kind of information only, that is initial slot and the kind of vehicle. From these two information, we can easily identify that the bus is parked in the seventh slot. We have a common knowledge, we have a common information. Bus take 4 slots, so we can easily identify that bus takes 7, 8, 9, and 10. That means 7 onwards it take 4 slots to park that particular vehicle. This is more a efficient mechanism to handle the vehicle. We can park any kind of vehicle and we only needs to keep similar kind of information only in the register. For different kind of vehicle, we don't needs to keep the different kind of information. We only needs to keep the same kind of information. This make the register or wherever we are going to store the information more simple, right? I hope you got that point. The only thing we need to know that this kind of vehicle take this much slot. This additional information we require, and we can make our register more simple and we can efficiently handle. We can park any kind of vehicle and we can keep the register for that parking slot very simple also. So this is a little more efficient mechanism to park our vehicles, right? So once when we think that in future there is a little more bigger vehicle came, right? For example, an a big truck, right, that take 10 slots. What we need to do, we don't need to do any kind of changes in our registry or the mechanism we are going to keep the register. We don't need to change any kind of vehicle. We only needs to add that particular vehicle in this information, in this knowledge. We can add a truck that take 10 slots and we can park it in the 10 slots, and we can store the information, parking information, in the same way we used for all that kind of all other vehicles. So this is a more simple mechanism to park the vehicle, and it is also an efficient, right? C++ use the same kind of mechanism. I'm saying C++ use the same kind of mechanism. And in earlier cases, we have a parking slot. In case of C++, to store the data, it use the memory. We already learned that in the previous chapter. To store any kind of data, C++ use the memory as the storing mechanism. It store all kind of data in the memory, right? So what kind of data it needs to store? needs to store the variables, right, or the data associated with a variable. We learned that in the previous chapter. And every variable has a data type, and all the data type has a different kind of storage required. Okay. C++ defined some fundamental data types, and we can create an custom data type also. We can learn that in the next chapters. But just now, think that we have two kind of data: fundamental data types and the custom data type. All kind of data, even though it is a fundamental data type or it is a custom data type, C++ stores or keep an additional information how much data it required to store in the memory. Okay, similar way we kept how much slots required for each kind of vehicle. The similar way, C++ stores that how much slot or how much storage required to store each kind of data type. This is an additional information C++ kept, right? So, in case of memory, we divided at different slots. Similar way, we divided our parking slots, and we given each slot a number. In parking slot case, we given a slot number. In the similar way, in the memory also, we given a number. This number is called the address, the memory address. I am introducing a new term here. It is called the memory address. Please note that this is a very important term in case of a memory. Memory management is a very crucial part in C++ programming. So it is very important to know that how we handle the memory, how the C++ stores the data in memory. This is a very crucial knowledge. That's why I am repeating that term. And in case of memory, I am introducing a term that's called the address, memory address. This term is also very important to understand the memory. This is very simple. Address is to identify a particular memory slot, right? Normally the memory is divided as bytes. So let's think that our memory is divided as a byte, and each byte we give a number, and that number is called the memory address, right? This is the first address, this is the second address, like that. And in case of C++, let's think that we have this much fundamental data types. C++ define that bool take 1 byte, character take 1 byte, integer take 4 bytes. These are the bool, char, or int are the fundamental, some of the fundamental data types in C++. There are more fundamental data types. We can learn all in next chapters. But currently, just assume that we have this much data types. And C++ defined that how much memory it required to store in memory. The similar way we defined for the vehicles, C++ defined that for each data type, it required this much storage required in memory. Okay. So we comes a Boolean kind of data we stored in the memory address one. The similar way we parked a vehicle, right? When comes a bike, we parked it in the slot one. Similar way, when comes data of Boolean type, we store it in the memory address one. We kept a register for parking, right? The similar way, C process keep an data which address contain which data types. Okay, for address one, it kept a data type as Boolean. So it knows that in the first address, it has an it only take the first byte, right? Because Boolean only take 1 byte. So we have to store a character also 1 byte. So we can address the similar way, right? Like the same way, when comes an integer that takes 4 bytes, but we can use a similar kind of register, right? The we stored the integer in 4, 5, 6, and 7. Like the similar way we stored a bus, right? It take the 4 bytes, so it take this much bytes for 5, 6, and 7. This much addresses it used to store the integer data type. But when it comes to the registry, we only need to store the initial address, and we only need to keep an information what kind of data it has. Okay, from these two information, we can easily identify that fourth address, data type is integer, integer takes 4 bytes. We kept that as a common information. So C process knows that integer take 4 bytes. So they can easily identify that from fourth byte, 4 byte it used to store the integer data type. So when we come to how much information we need to keep this kind of memory, only this much information is required, right? The initial address and the kind of data type it has, and we have a common knowledge. Using this information we can easily manage the memory, right? C process also easily manage the memory like that. Just think that it don't keep an table or some kind of information like this. This is just a symbolic way. C process may store this kind of information or use this kind of information, but it is not saving as a table or something like that. It has a different mechanism. But from a conceptual point of view, it stored this kind of or this form of data. Okay, we can learn it detail, how the C process stores the memory and how it get the memory using the pointers when we needs to access the data in the coming chapters. Okay, I think that's it for this chapter. This is a very crucial chapter because memory handling is a very crucial thing in C process. Okay, uh, whenever you handle the memory, you need to try to visualize the memory. Then you can easily handle the memory, because memory is uh, gives us a lot of advantages. At the same time, it gives some of the disadvantages also. It can easily corrupt the data, it can easily crash your program, and there is a point of buffer overflow, that kind of things. So if you handle the memory in the wrong way, there are lot of issues comes in your program. So it is required, and so you need to have a very good understanding of memory when you do the programming in C++. The first thing is visualize the memory. Always try to visualize the memory. That is the best way to understand the memory. Okay, so you are a beginner, so in the beginning level itself, always try to visualize the memory. Okay, then when it comes to handle the custom data types or a very complex memory structure, you can easily handle the memory. I'm saying this from my experience. Okay, always try to visualize the memory. At the beginning level, you may think that why I need to visualize the memory, I can easily understand these kind of things, right? But just think that it is very important when you handle the complex kind of thing. So the initial state itself, just create a practice to visualize the memory. Okay, this is a very important thing. uh, okay, I think we can close this chapter. We can see it in the next chapter. Bye.